Show that it was recording. All right, so next week, we have that wonderful different schedule as we prepare to go back with everyone here. And then just it's the same hour schedule after next week, but you'll be here for both A and B cohort days. So you get to see me 4 days a week, yay!
Nobody else comes, right?
There's one student in the B cohort, but I think she only has like 2 classes. So I think both of the classes are allowing her to do it online, which is fine. I mean, that's whether I have one class in class, one student in class or one student online, it really didn't matter to me a whole lot. But so next week, Monday, we're at 50-minute class periods. And it'll be the same hours as normal, 1, 3, 7, and then 5 due to lunch. And then 2, 4, 6, 5. Wednesday will be it'll be like a no school day for students. Be a teacher kind of prep day. And then again, 1, 3, 7, 5, 2, 4, 5, 2, 4, 6, 5. So just a little bit different schedule next week. And then, as I said, in 2 weeks, it'll be first hour, all students, 8:30 to 9, to 10:15, and so it'll be the regular 105-minute block schedule. All right. Questions on homework from last week? Other than when are you going to correct it, Mr. Gingrich? Oh, I did post the answers last night. I had realized that I didn't post them yet, so I did put them in. I think it's in the lesson 14 folder. There's one that says solutions. So they are there for you. Today and tomorrow we're going to talk about, today we're going to talk about one-sided limits. Tomorrow we'll talk about continuous functions. Again, some pretty big ideas for calculus, and as we move forward, but also some pretty straightforward ideas, I think. So, one-sided limits. If we approach C, so if we take the limit as x approaches C from only one side, so either from values less than C or values greater than C, we have this thing called a one-sided limit. A left limit occurs when x approaches C from the left, from values less than C. The notation is the limit as x approaches C with a little negative sign in the kind of a superscript of f of x. So just remember that means C approaching C from the left and not approaches negative C. I have students confuse that quite often. A right limit occurs when x approaches C from the right, values that are greater than C. And that is noted by the limit as x approaches C with a plus sign in the superscript of f of x. This one-sided limit idea is important and useful for certain functions. Things like even roots, square roots, fourth roots, sixth roots, eighth roots, where it's only defined for certain values. Like if we had the square root of x, we couldn't approach the square root of, we couldn't have x approaches 0 for the square root of x because it's not defined for values less than 0. We would need a one-sided limit. Logarithm, ln, another case. And then also, if we have piecewise defined functions, one-sided limits work really well. Right? So this idea of the limit then, let's suppose that as x approaches c from the left, our function has a limit value of L, so this is left and L. And as x approaches c from the right, our function has a limit of R. Then the function, the limit of the function exists if and only if L and R are the same value. And that limit is whatever the value is for L and R. If L and R are not equal, then the limit does not exist. Again, I really like looking at these graphically. And so we're going to do one example, and we're going to do it actually two different ways. We're going to do it using the function, and then we'll look at the graph. And you can choose which way you like. So here we have a function, f of x is equal to 2x minus 1 if x is less than 2. The function is equal to 1 if x is equal to 2. And the function is x minus 2 if x is greater than 2. And we're going to look at three limits. The limit as we approach x from the left, as we approach x from the right, and then just the limit as we approach x. So using the, excuse me, using the functional notation to find the limit as x approaches 2 from the left, we have to look at where or how our function is defined for values less than 2. So for this, for the limit as x approaches 2 from the left, we have to use this definition. So this would be 2 times 2 minus 1. Pretty sure that's 3. Not sure, not positive. Yes? Okay. For the limit as x approaches 2 from the right, we have to use the definition where we have x greater than 2. So we're at that definition. And that would be 2 minus 2, or 0. So The limit as we approach 2 from the left is 3. The limit as we approach 2 from the right is 0. Is the limit as we approach from the left equal to the limit as we approach from the right? No. So the limit does not exist. Now that's looking at it from the just purely the function standpoint. If we wanted, we could graph this. And so what I'm going to do is graph that function. Oops. All right. So I'm going to give myself a little bit of room. Counting by halves. So the limit, or 2x minus 1 if x is less than 2. So what I'm going to do is start with, well, at 2, this has that value of 3. But it's not defined there, so I'm going to use a circle, open circle. And then I can graph the line. It's going to look something like that. Except it didn't put the ending like I wanted. There we go. When x equals 2, my function equals 1. And when x is greater than 2, I get 2x, I get x minus 2. And so if I think about the limits, the limit as I approach x from the left, as x approaches 2 from the left, basically I'm ignoring the right-hand part of everything that's 2 or greater. And then as x approaches 2 from the right, I ignore everything that's less than 2. So that's one way to think about it. The other way to think about it is, I think I talked about this, you can use your fingers. So as I approach 2 from the left, I'm just following this until I get really close to 2. And the closer I get to 2, the closer my finger gets to a y value of 3. The limit as I approach 2 from the right, I get closer and closer to 0 as a y value. The limit as I approach 2, then is I use both fingers, and they don't meet, so the limit does not exist. Big assignment for you. Almost impossible. I'm not sure if I know how to do it, so